In this video, we're going to discuss how to use the graphing calculator to describe a function and then also to identify local minimum and local maximum. So what we're going to do is we're going to go ahead and go over here to the calculator. And on the calculator, we're going to go ahead and type in our function. So 2x squared plus 3x minus 4. Okay, when we type that in, then we're going to go ahead and hit graph, and we're going to take a look at our graph. So we see here that our graph is a parabola. Now, before we can identify the intervals in which it is increasing and decreasing, we do have to identify, we see here in this particular graph that we do have a point here that I would consider to be a minimum point. So we're going to first of all identify what that local minimum point is. So the way we do that is we go to we hit second function and hit calc. That brings up this screen here. And we're going to go down here to minimum. I'm going to hit enter. And that's going to ask you for a left bound. So you'll see the cursor there on the curve. So we want the cursor to be to the left of that minimum point, which the minimum point is right here. We're going to hit enter, and then you'll see it asks for the right bound, so we're going to move that cursor over to the right, again anywhere to the right of that low point. Also hit enter. Now it says guess. We don't have to guess, we're just going to go ahead and hit enter and see what that local minimum point would be. And we see here the local minimum point on this graph would be an x value, which is this point, negative 0.75, and the y value, a negative 5.125. Okay, so again, the calculator has identified that local minimum point. Now, as we look at the graph, I'm just going to kind of trace here on the graph. Let me go back here to where we can, let's just go to trace. Okay, so we've hit trace, and you'll see here now that I can trace along this graph. So I'm up here at the top. We know that this graph is going to continue from positive infinity. So from positive infinity, it's going to go all the way down to this local minimum point. Well, that path that it's taking, that interval is going to be from negative infinity all the way to the x value of negative 0.75. And that is going to be a decreasing interval. Spell decreasing correctly. And then we know once we get to that point, it's going to start to go back up all the way to positive infinity. So from negative 0.75 all the way to positive infinity, that is going to be an increasing part of our function. So again, let's just take a look one more time at the graph. Again, notice from negative infinity all the way to negative 0.75, that's decreasing, and from negative 0.75 all the way to positive infinity, it is increasing. So that's kind of how we would describe this particular graph. This here would be what we would consider to be a local minima, because it's kind of a minimum point in my graph.